In this video, we're going to solve some more advanced absolute value equations. So these are more advanced than what we solved in the textbook because when we start by fully simplifying the equation as much as possible, and what's going to result is something more complicated than just having one absolute value expression on one side and a constant on the other side. Or at the most complex, you have just one absolute value by itself on one side and one absolute value expression by itself on the other side, and that's it. So you can see here, this is, we don't have, we have two absolute values, but they're not just like, there's just, we can't simplify it to one on one side, one on the other side. Here we've got an absolute value nested inside of another absolute value. Here we've got two absolute values, and we have a quadratic inside one. So, okay. But the general procedure we talked about, the way to approach solving absolute value equations that we talked about in the textbook, and even in the previous example problem video on the simpler absolute value equations, that applies to, you use that procedure to solve any absolute value equation, no matter what it is. So what we're going to do is, we start by simplifying the equation as much as possible. This is already fully, we can't simplify this any further, so we would start by combining like terms, dividing things by multiplying things on both sides to simplify it. We can't simplify this any further. So now we're going to go into the analysis of, okay, we go to each absolute value in the entire equation and solve for when the expression inside the absolute value equals to 0, or really what you're looking for are all the crossover points in terms of the x values that where it switches from positive to negative is what you're looking for, the expression. Now, as I mentioned, as far as, okay, well, you know, certain expressions, how can we figure out where they cross over from positive to negative? If we're dealing with a polynomial, any kind of polynomial, then just find where that equals 0. That's going to be the potential crossover points. But other expressions, it's a little more complicated. Don't worry about that too much here in algebra. When you're done with calculus, you'll be able to look at any expression, no matter what it is, and find all of its crossover points easily. So, but we're only going to be working in algebra in this course with polynomials inside of the absolute value. In that case, you just need to solve for where the polynomial equals 0. Those are the only points where it could change from positive to negative. So, okay, from there, then what you want to do is draw a number line. We're only going to be considering, with absolute value equations in this course, we're only going to be considering where values of the variable are real numbers, because it gets a little more tricky with, if we're considering complex numbers, then what does an absolute value mean in terms of complex numbers? We can absolutely think about absolute value equations with complex numbers, but that's just beyond the scope of this course. We'll come back to that in complex analysis. So assuming we're only dealing with real numbers, okay, we want to plot all of the crossover points. So with these linear expressions here, there's only going to be one crossover point, but you can, you know, we're going to, with the last problem, we're going to have a quadratic. There's going to be two crossover points. So you want to plot all of the crossover points. So let's see, I'll just put 0, but then one is going to be 7/2, positive 7/2. That's when 2x minus 7 equals 0. Another is going to be minus 5/3. So now let's put these boundaries here so we can clearly see the boundaries. 0 is not a boundary. So now we've got these, what this shows us is we have these three separate regions that we need to analyze, okay? And so what we're going to do is we're going to go to these three separate regions. Now we want to, well, we're trying to analyze the equation for every single possible x value in the domain, so that's all real numbers. So we want to make sure we do that. So it's important to consider if we're saying, okay, we're analyzing if x is greater than or equal to this, or less than or equal to this, because we want to make sure we also analyze these boundary points as well. So, okay, let's first look at if x is, let's see, greater than or equal to 7/2. And I'm saying greater than or equal because the general way we simplify absolute value expressions is if the expression is going to be inside the absolute value is going to be positive or 0, then we just remove the absolute value. And so that's what, if x is greater than or equal to 7/2, this is going to be positive or 0. So, and then this is just always going to be positive. So in this case, we just remove the absolute values because that's how, because we're considering just these x values. Okay, and Now we just solved the equation. And one thing, I'm not sure if I mentioned this, but if you're wondering, well, what kind of equation do I call this? What category of equation is this? I know it's absolute value, but like, is it linear absolute value, quadratic, etc.? You just look at, so for every time, every equation we have to solve, it's going to be the same type of equation. What type of equation is this? This is a linear equation. Every one of the equations we're going to have to solve is going to be linear. So this is linear absolute value. You look at what type of, whenever you're going through the different regions and you're solving these, you're removing the absolute values and solving the equations, what type of equation are you solving? Is it quadratic? Is it, or at least the most, if for some reason, maybe it's the case that you're solving different types of equations, what's the most complicated one? If for one case we had to solve a quadratic, for another case we had to solve linear, then you're going to call it quadratic absolute value. That's the idea. So, okay. 2x minus 2x is 0, plus 3 minus 7 is minus 4. That's not equal to 21, so there's no solutions in this region. There's no x that's greater than or equal to 7/2 that's going to solve this equation. Okay, but now we need to analyze. Let's keep going. So now we'll do x is less than 7/2, because the way we simplify absolute values in general is that if this is negative, but not equal to 0, but just negative, what's the expression, 100% for any x value we plug in, then we just remove the absolute value and put a negative out front. Okay, and then we'll do greater than or equal to minus 5/3 here, because that would make this 0 or positive. So, okay, we just remove the absolute value here, and then here we put a, let me do another bracket. We put a negative out front to simplify this. Okay, so 5x plus 3, and now minus 2x plus 7. Okay, so we've got, let's come over here. We've got 5x plus 3 plus 2x minus 7 is equal to 21. 5x plus 2x is 7x. 3 minus 7 is minus 4. 21 plus 4 is 25. X is 25 over 7. Okay, is that between 7/2 and 5/3? So let's see. Or 7/2 and minus 5/3. So minus 5/3. Now what is 25 over 7? Now what is 7/2? No, it's not. So this is not a solution. And so there's no solutions in this region. Now, okay, last we just need to do x is less than minus 5/3. And now we've accounted for all points. So if that's the case, then both of these are negative. 5x plus 3. And then this simplified as we're going to get plus 2x minus 7, right? Okay, so minus 5x minus 3 plus 2x minus 7 is equal to 21. So minus 5x plus 2x is minus 3x. Minus 3 minus 7 is minus 10. So minus 3x is equal to 31. So x is equal to minus 31 over 3. Is that less than minus 5/3? Yes. So this is the only solution. And wait, what did I do? Okay, for some reason I put 2x here. I don't know what. Okay. So, no, this is, both are positive. So we've got, I put 2x. This is 5x plus 3. Then minus 2x plus 7 is equal to 21. So 5x minus 2x is 3x. 7 plus 3 is 10. 10 minus 21 is 11. So x is equal to 11/3. Is that greater than 7/2? Let's see. 2 times, that's 3.5. Okay, let me check. It's hard to see for sure. So 11/3 and 7/2. So yes. So this is a solution as well. There's two solutions. Okay. So now here, let's put the boundary points. So we've got x is equal to 1 and x is equal to 1/3. Okay. So let's do, if x is greater than or equal to 1, then both are going to be positive. Okay, x plus 3x is 4x, minus 1 is 2. 5 plus 2 is 7. X is equal to 7/4. Is 7/4 greater than or equal to 1? Yes. X is equal to 7/4 is a solution. Okay. What about if x is less than 1 and greater than or equal to 1/3? Then this is going to be negative. So x minus 1 is always going to be negative. This is going to be positive or 0. So we just remove the absolute value. Minus x plus 1. Okay, minus x plus 3x is 2x. 1 minus 1 is 0. X is equal to 5/2. Is that between 1/3 and 1? No, so that is not a solution. Okay, so now we just need to do x is less than 1/3, and that would account for everything. So now here both are negative. Minus x plus 1 minus 3x plus 1. Okay, minus x minus 3x, 1 plus 1. 5 minus 2 is 3. Okay, is this less than 1/3? Yes, it is. So that's a solution, and we've accounted for all of the regions, so those are the two solutions. Okay, here we have an absolute value nested within another absolute value. All we're going to do to solve this is, so let's consider the inner absolute value where that crosses over 0. So that's going to be at minus 4/9. Okay, now we're just going to consider the intervals that are greater than minus 4/9 and less than minus 4/9 for the big picture problem here. So, okay, if x is greater than or equal to minus 4/9, then 9x plus 4 is going to be positive or 0. So let's, for this entire equation here, let's analyze this equation just for values of x that are greater than or equal to minus 4/9. Well, in that case, we can just remove the absolute value around the 9x plus 4. Okay, so, but now let's solve this absolute value equation. Okay, so 9x minus 6. All right, but as we're solving this, we have to keep in mind that we're restricted to these x values. Okay, so, all right, but same process here. X is going to cross over at, or 9x minus 6 crosses over at 6/9. That's 2/3. Okay, so we've got, all right, now, but we're only dealing with anything greater than or equal to minus 4/9. So, you know, if we were only dealing with values greater than or equal to 1, for example, then we wouldn't have to analyze two equations here because it wouldn't matter anyway. But here, since we're greater than or equal to minus 4/9, we are going to have to analyze both above and below 2/3. So that's fine. So, okay, if we're greater than or equal to 2/3, then let's see. 9x minus 6 is going to be positive or 0. So 9x minus 6 is equal to 21. 9x is equal to 27. X is equal to 3. Okay, is 3 greater than or equal to 2/3? Yes, it is. Is 3 greater than or equal to -4/9? Yes, it is. So this is a solution. Okay, but now we need to do when x is less than 2/3. In this case, 9x minus 6 is always negative, so we do multiplying both sides by -1, adding 6 to both sides. -21 plus 6 is -15. Dividing both sides by 9, you get -5/3. Okay, is that less than 2/3? Yes. Okay, now is that greater than or equal to -4/9? No, no. So that's not a solution. Okay, so there we go. So now we need to analyze when x is less than -4/9. In that case, 9x plus 4 is always negative, so we do this. Okay, so minus 9x minus 4 minus 10. Okay, minus 9x minus 14. Okay, so at x is equal to -14/9 is a crossover point. Okay, but now you want to be careful. You don't just analyze this on the entire left and the entire right. You have to remember we're only in this region here. So where's -4/9? That's somewhere in here. So let me draw this again. So -4/9 minus 14/9. So, okay, so we are going to have to analyze two equations. I mean, sometimes it happens to where, like, if minus, it might be the case that, like, sometimes you'll work problems with, like, nested absolute values like this, and you only have to analyze one side of, for example, if this was x is greater than -4/9, then we'd only, here's the boundary for this absolute value equation. We don't have to analyze this side. But in this case, for both of these, we have to analyze both. So, okay, if x is, let's start with less than or equal to -14/9, then minus 9x minus 14 is going to be positive or 0. So we just remove the absolute value, add 14 to both sides, -35/9. That is less than or equal to -14/9. And it's also less than -4/9, so that's a solution. Okay, now what about when x is greater than -14/9? In that case, minus 9x minus 14 is always negative, so, okay, multiplying -1 on both sides. Okay, minus 9x is equal to -21 plus 14 is -7. X is equal to 7/9. That's greater than -14/9, but that's greater than -4/9. So no, these are the only two solutions here. Okay, here's another nested absolute value problem. Let's look at the absolute value in the middle. We've got, that's going to change signs when x is equal to 2/5. Okay, so let's consider when x is greater than or equal to 2/5, then 5x minus 2 is always positive or 0, so we just remove the absolute value. Okay, -2 minus 6 is -8. Okay, so now this, let's solve this. This crosses over at 8/5. So there's the boundary. Now, where the interval we're dealing with is 2/5. X is greater than or equal to 2/5, so we're going to need to consider both. If sometimes it happens where this is greater than or equal to, like, or greater than 3. Well, in that case, we only need to consider one. We don't have to solve one equation because we're not going to have to go to the other side anyway. You see? So like you want to distinguish between what your boundary is for this like sub absolute value equation, what the boundary is, and what this kind of outer restriction is. So, but yeah, we have this restriction is here, so we have values both to the left and to the right of the boundary for this absolute value equation. Sometimes that's not the case. So okay, we start with, let's see, x is greater than or equal to 8/5. That means 5x minus 8 is going to be positive or 0. So, okay, add 8 to both sides. Divide both sides by 5. X is equal to 2. That is greater than or equal to 8/5. So this is a solution. Okay, let's do x is less than 8/5. In that case, we've got, this is going to, 5x minus 8 is going to be negative. So we do multiply both sides by -1. Add 8 to both sides. Minus 2 plus 8 is 6. Divide both sides by 5. 6/5. That is less than 8/5. And that is greater than 2/5. So this is a solution. Okay. So now let's go in the other direction. So x is less than 2/5. In that case, 5x minus 2 is always negative. So, all right, we've got, okay. Okay, so where do we cross over here? We cross over at minus 4/5. There's the boundary. Now we're dealing with x is less than 2/5. So I wish they would have had an example where we only had to do this on one side, but all of these we've had to do it on both sides. So, okay, we've got, let's see, 0 minus 4/5, but there's the boundary for this absolute value equation, and then we've got positive 2/5 here. So we're going to need to consider this region and this region. So, all right, when x is less than or equal to minus 4/5, minus 5x minus 4 is positive or 0. So minus 5x minus 4 is equal to 2, minus 5x is equal to 6, x is equal to minus 6/5. That is less than or equal to minus 4/5, also less than 2/5. So this is a solution. Okay, now what about when x is greater than minus 4/5? Okay, so remove the absolute value, put a minus, is equal to 2. So, okay, multiply both sides by -1. Add 4 to both sides. Minus 2 plus 4 is 2. Divide both sides by -5. Okay, so minus 2/5 is greater than minus 4/5. And it's less than 2/5. So this is a solution. So these are the 4 solutions. Okay, so how do we solve this? Well, this is just, we have this one absolute value here. The boundary point's at 0. So, okay, we start with x is greater than or equal to 0. So that means this is going to be positive or 0. And we remove the absolute value and just solve the equation. Get answers and see if they're in this region. So this is just a quadratic equation. So we just need to solve a quadratic equation. So we've got, let's see, 5 times 2. Let's see if we can factor this. So 5 times minus 2 is minus 10. So we could do minus 10x plus x. Yeah, and we haven't changed the equation. So now let's factor out a 5x, x minus 2. And then we've got x minus 2 over here. So now we can factor out a 5x plus 1. Okay, so x is equal to minus 1/5, or x is equal to 2. Okay, but which one is x is equal to 2 greater than or equal to 0? Yes, it is. So this is a solution. Is x is minus 1/5 greater than or equal to 0? No, that's not a solution. That's it. Same type of process. So, okay, we've done this region. Now let's just we got to cover everything. So if x is less than 0, then we simplify, we simplify this by taking a minus sign out. So, okay, so let's see. Can we do this? Are we able to? I think we can. We can say plus 10x minus x. Yeah, that's going to work as well. So take out a 5x here, x plus 2. Take out a minus here, x plus 2. So 5x minus 1 times x plus 2. So we've got x is equal to 1/5. X is equal to minus 2. Okay, is minus 2 less than 0? Yes, it is. Is 1/5 less than 0? No. So these are the only two answers. Okay, we just go to every single absolute value and find all of the boundary points, the crossover points. And since we just have these polynomials, we just need to solve for where they're equal to 0. So here, x squared minus 4 is equal to 0. Well, okay, x plus 2, x minus 2, x is equal to 2, x is equal to minus 2. Okay, and then x plus 6, that's equals 0, and x is equal to minus 6. So we've got 2 minus 2 and minus 6. So we've got these, let's see, 4 separate regions to analyze. All right, so let's just, it's going to take a little time, but that's all right. Let's start with x is greater than or equal to 2. In that case, what happens? So if x is greater than or equal to 2, this is always going to be positive, and this is always going to be positive. So yeah, we can start here. We might end up getting the same equation more than once, so we can keep that in mind so we don't have to solve the same equation twice. So, okay, we just remove this absolute value, and we just remove this absolute value. So 3x squared minus 12 minus 2, 7x plus x is 8x, 3x squared minus 14. Okay, 3x squared minus 8x, and subtracting 6 from both sides, minus 20 is equal to 0. Okay. Let's see. 20 times 3 is 3 times negative 20 is negative 60. So we've got, let's see, minus 15 times 4, minus 5 times 3 times 4, minus 5 times 3 times 2 times 2. Can we get anything that would make an 8? It doesn't look like it. So we can't factor this. Let's just use the quadratic formula. So minus b plus or minus, and then, so b squared minus 4 times a times c, 304, 4 root 19, all over 2 times a. So, okay, we could simplify this by like that. So, okay, but which of these two are greater than or equal to minus 2? So minus 4 minus 2 root 19 over 3 is not going to be greater than or equal to 2. But what about minus 4 plus 2 times root 19? That's not greater than or equal to 2 either. So neither one of these are solutions. Okay, but in general, you don't want to erase the solution here in case you get the same equation twice. And this could come up in this scenario because of this x squared here, right? So like, even if you have a negative value, you still it's like it has a kind of a symmetry about it. So because we don't have to solve this same equation again. We could just reference it, the solutions, and compare to the new interval. So let's just see how this goes. We've done this region. Now let's do between Okay, so let's see. Between minus 2 and 2. So if we're less than 2, this is always going to be negative, well, assuming we're also greater than 2. Now this is always negative, x squared minus 4. And this is always positive. So let's do that. We're going to take out a negative here. Okay, minus 3x squared plus 12 minus 2 is equal to 8x plus 6. Okay, minus 3x squared plus 10. Okay, so 3x squared plus 8x, and then 6 minus 10 is minus 4. Okay, so 3 times minus 4 is minus 12. We've got minus 6 times 2. So can we do, let's see, let me make some room here. Okay, it looks like we can do 3x squared plus 6x. Or no, okay. Minus 6x minus 2. No, we can't factor this. So, okay, and that's fine. So quadratic formula, minus 8 plus or minus b squared. Let me just plug this in. B squared minus 4 times a times c. 4 root 7. So, okay. All over 2a. So we've got, let's see, minus 4 plus or minus 2 root 7 over 3. Okay, so let's do, okay, minus 4 minus 2 times root 7 over 3. So, okay, that's outside of the range. Okay, now let's do minus 4 plus 2 root 7 over 3. And that's within the range. So, there we go. There's one solution. Minus 4 plus 2 root 7 over 3. Okay, now we've done this region. All right. Now, let's do x is less than or equal to minus 2, which would mean that this comes back to being positive or 0, and x is greater than or equal to minus 6, which means that this is positive or 0. Now, okay, they're both positive or 0. So we're doing this region here. They're both positive or 0. But we already did that. We already solved that equation. When x was greater than or equal to 2, this was positive or 0, this was positive or 0. So we already have the solutions. This minus 4 plus 2 root 19 over 3. Okay, so we don't need to solve the equation. We just write the solutions. But we do need to go ahead and compare these to this new interval, because they might be solutions in this new interval. So minus 4 plus 2 root 19 over 3. 1.57, no. And then we didn't do, okay, so divided by 3 minus 4.23. That is a solution. There we go. So okay. So now we've got one more region to go. X is less than minus 6. X is less than minus 6. So, okay. In that case, what's going to happen? This is going to be positive, and this is going to be negative. Did we already do that? I don't think so. No. So we need to go ahead and solve this. So this is going to be positive, and this with a negative out front. Okay, so 3x squared minus 12 minus 2 is equal to 7x minus x minus 6. So 3x squared minus 14 is equal to 6x minus 6. So we've got 3x squared minus 6x. Adding 6 to both sides, we get minus 8. So 3 times minus 8 is minus 24. So, okay, minus 6 times 4 minus 3 times 2 times 2 times 2. So, okay, 8 and 3, no. 12 and 2, no. 6 and 4, no. So, okay, let's just do the quadratic formula. So, x is equal to minus b plus or minus, and let me just plug this in to the calculator. So, b squared minus 4 times a times c, and then put that into, so 2 root 33 all over 2a. So x is equal to 3 plus or minus root 33 over 3. All right. Well, the 3 plus root 33 over 3 is definitely not less than minus 6. But what about 3 minus square root of 33 over 3? No. So neither one of these are solutions. So these are the only two solutions. Now we've accounted for all of the regions, right? Every single potential x value. So those are the two solutions. Okay, and I think I just checked this answer. This should be 4 plus 2 root 19 divided by 3. So did I miss something here? Yeah, this is minus b. This is just a plus out front. So yeah, I mean, you get the idea. It's going to be, this should be a plus out front, and so this is going to, and then, but if we came back and still compared both of these solutions to x being greater than or equal to 2, none of these would check out. But here only 4 plus 2 root 19 square root 19 divided by 3 would check out. So these are the two solutions.